Section 13.2, define general angles and use radian measure. More trig stuff. Yay! Okay, so first let's define some terms. We're dealing a lot with trig. We're dealing with a lot of angles. So the initial side of the angle is the angle that stays where it is, and then the terminal side is the one. What happens is with an angle, you're opening, and so the initial side is the one that stays, and the terminal side is the one that opens and stops at whatever angle. All right. So the initial side is the static side, and the terminal side is the side that opens. The standard position of an angle is if your vertex is at the origin. If the vertex is at the origin and you open with your initial side on the positive x-axis, and you're opening usually you're open, actually positive and negative. If you're opening counterclockwise, then this is positive. If you're opening clockwise, then that's a negative angle if you're going downward. All right, so that's negative and positive angles. All right, we covered all of that, all of the basics. So what I'll ask you to do is, okay, so if I want an angle that is 135 degrees, you've used a protractor to measure angles. What we're going to do is we're going to open this angle 135 degrees. And what you can do is you can kind of estimate some of these. So you can look to see if I'm going to start in the, and I didn't say, I said that in the directions, but I didn't write the directions down. I want you to open this in the standard position. I want you to draw me an angle that is 135 degrees in the standard position. So what's going to happen is you're going to start with your vertex at the origin, and you're going to start at the positive x-axis, and you're going to start opening. And if you'll notice, 90 degrees plus 45 plus 45 degrees equals 135, right? And 45 is about half of 90. So if you open, here is 90 and about half of this, so there's your angle right there. Ta-da! So the angle is from here to here. So that would be 135 degrees. Now, what if you have something that is 640 degrees? Well, you can still you start with your initial angle, and then your terminal angle is going to have to just keep opening and opening and opening. So you start by counting, well, it's kind of like counting money where you count the dollars first and the quarters next and then the dimes. And so what we're going to do is we're going to count a whole circle as 360 degrees. And we're going to have a whole 360 degrees inside this 640. Then we're going to have another 180. What would that be? 3, 4, 534, 540. So we need another 100. So that's going to be plus, we go in 90s because that's how much of that's a fourth of our circle, right? Plus 90 plus 10. Whew! Okay, so then when you go to draw it, you're going to start here at your initial angle, or your initial side, and you're going to go around and say, okay, there's 360 degrees. Now there's another 180, here's another 90, and here's about 10. So my angle is going to be right here, but this shows how far we opened that angle. So that snaky, swirly thing is showing how far this angle, this side, this terminal side had to flip all the way around more than 1.5 times in order to get to here. All right? Okay, so now if I want a negative 105 degrees, what I'm going to do is I'm still going to start at the same place, and I'm going to, so I had to mark it with my angle to show, or with my line to show where did I open, which direction did I go. So I'm going to start at the initial side, and I'm going to go clockwise now, and 105 is going to be 90 plus 15 more. So, and I'm working with 90s because of my quadrants, right? So I'm going to start at this initial side, and I'm going to go 90 in the negative direction, plus another 15 is about there. And you know my lovely lines are never straight. But there's about 105 degrees, negative 105 degrees. All right? So that's how to open the angles, and that's how to measure the angles. Now, coterminal angles are angles that have a coterminal side. So they have a terminal side that is shared. So what happens is this angle could open this way, or it could also open this way. So if I want this coterminal, so this coterminal angle of 640 went all the way around this way, but it could also be with this terminal side. I could have said, well, I can open it this way, and in this case, I would have, what is that? 90 minus 10 is 80. So this would be a negative 80-degree angle. So a negative 80-degree angle and a 640-degree angle have the same terminal side. All right? And the way you're going to do that is this. You're going to take, oh, and I didn't put my little degrees. These are degree. What you're going to do is, this has to do with the number of times you're going all the way around the circle. So it's going to be in sets of 360, all right? Because you would take the, you can take 640 and subtract 360 off and get this same angle. I actually backed up and took 360, two 360s off of that one. So what you're going to do to find angles with coterminal sides is you're going to either add or subtract sets of 360. So to get this 215 degrees, if I say, okay, I want a negative 215 degree angle, I want two angles, one positive and one negative, that have coterminal angles that have the same ending. What you'll do is you'll take this negative 215, and if you add 360 to it, if you add 360 degrees to this 215, you get 145, I hope. 2, 3, 40, 50, 60, yes. So a 145-degree angle is going to have the same ending point that a negative 215-degree angle is, because we just don't go around as far or as many times. All right. So then to get a negative angle that's going to be coterminal with this, we would just subtract 360 degrees from that. And of course, if you have two negatives, you actually add. So that angle is going to be a negative 575-degree angle. So here with a 570-degree angle, if I subtract 360 from this, I'm going to end up with 210 degrees. 5, 6, 7, 8, 3, 4, 5, 6, yes. All right. Now this is a positive, 210 is a positive angle. So if I want a positive and a negative, I'm going to have to take this and subtract 360 from it to get a negative angle. But I can just do that. I can add or subtract 360 from any of these coterminal angles, and I'll get another coterminal angle. So because what we've done is just don't go around as far. Don't go all the way around. Go the other direction 360. All right. So this one would end up being a negative 150-degree angle. So here are my two coterminal angles, one positive and one negative, for 570 degrees. All right. Whew, we got a lot today. Here we go. Now, so not only do we have all of these angles, and I don't think that's difficult. It's just kind of, wait, we're spinning around the circle 2 times. Now what I want you to do is we're going to use radian measure. Now on your calculator, you have degree measure and radian measure. And if you've been working in radian measure, and we've been doing some of these sine or cosine, I think in the last section I said, make sure your calculator is in degree measure. So I'm going to show you what this radian measure is all about. And so hang on, here you go. So you've got a circle, and the distance between the center of the circle and the edge, you know, is the radius. If you take that radius, the length of that radius, and stretch it over the edge of your circle, if you stretch it one time, that one length of the radius is called 1 radian. So the angle that occurs when you open that angle, the distance of 1 radius, that is called 1 radian. All right? So 1 radian equals the length of the radius. And so 300, and because the whole circle is, you remember the circumference of the circle is 2 pi r, so 360 degrees is 2 pi r radians, or 2 pi radians, because the r is your radius. So it goes to, the radius will go 2 times pi around your circle. So therefore 180 degrees is actually pi radians. Okay, so you may have to pause and let that sink in and figure in your brain. So 180 degrees is pi radians, so 3.14 radians. The radius will go about 3 times till it gets to the other side. All right, now in order to convert degrees, which we're used to working with, into these radians, you're simply going to take whatever degree measurement that you have and multiply it by pi over 180. So in other words, you'll divide by 180 and then multiply by pi. All right, and if you have the radians and you want to switch it to degrees, you're going to multiply by 180 degrees and divide by pi. All right, let me show you how it's done. Here we go. We are going to convert this 75 degrees. I want to convert it to radians. So I'm going to use this conversion, degrees times pi radians over 180. So just multiply by pi radians over 180. And so when I do that, I simply reduce down. What do I reduce by? 75, 25, 25. 5 and 12. That's right. Okay. So then when I multiply across, 5 pi over 12 radians. And that's all we do. So just use that conversion. All right. So if I have radians, if I have negative 5 pi radians over 4, and I want to switch that to degrees, now I'm just going to use this conversion. So multiply by 180 degrees over pi radians. So now the pi will cancel, and my 4 will cancel. How many times does 4 go into 18? 45, I think. So then when you multiply negative 5 times 45, you get negative 225 degrees. Ta-da, done. All right? So really and truly with that, it's just a matter of remembering, oh, 180 degrees is my conversion, and make sure you have either pi over 180 or 180 over pi. And there's your conversion. All right? One last thing for today. So we can convert between radian measure and degree measures in angles. Now what we're going to do is, oh, guess what? Look, I have definitions on here. A sector and a central angle. A sector is like a piece of pie. A sector is an area that is bounded by that angle, well, the central angle, which is from the center of the circle out to the edge. So a sector goes from the center of the circle out to the edge, and it's that area that's bounded by that angle. All right? So that's what a sector is. It's just a piece of pie. So I have a word problem here. I've got a game that kids are playing on a circular field, and this circular field has a radius of 18 feet. And I spelled that wrong. They have a safe zone, not a save zone. A safe zone, they're playing tag or whatever. In order to be safe, they have to be inside an area in this circular field that's bounded by a rope and 120 degree central angle. So I don't know if you can, if you can picture it, we've got a circular field. And inside this circular field, there is a 120 degree angle that makes a sector, all right? And so what I want to know, so this is 120 degrees, and I want to know how long is the rope, how long of a piece of rope do I have to bound this? How long is this arc length is really what I'm looking for in order to find this safe zone. Well, you're going to need some formulas here. So I happen to have them, and I probably, if I know you well, I know you've already got them written down. So the arc length is going to be defined by S, which is the length of the arc, equals the radius times the theta represents that angle. All right, I think we used that in the last section. I'm not sure. So theta is the angle that we're talking about, and this I want measured in radians. Okay, and the area of the sector is going to be defined by 1/2 the radius squared times theta, which is the area, or I'm sorry, the angle in radians. Now first, so that means I've got this angle in degrees, so the first thing I need to do is I need to change that angle to radians before I can put it into my formula. So what you're going to do is use your conversion. So the 120 degrees, do you remember what the conversion is already? 120 degrees, if I'm changing the degrees to radians, I'm going to multiply by pi over 180. And so that will reduce, ooh, that's easy. That's by 10, and by 6 is 2, and by 6 is 3. Oh, okay. So we just have 2/3 pi. So 120 degrees is the same as 2/3 pi radians. So now I can simply put those amounts into my formula. All right. So the arc length, the length of that rope, is going to be defined by S equals R, which is the radius. And we said the radius is 18 feet. Times theta, which is that angle in radians, so 2/3 pi. So now just reduce it down. There's 6, and 6 is 12, so 12 pi. And so for these, I'm going to want a final answer, so just put pi in your calculator, so 12 times pi, and I believe that comes up to 37.7 feet. All right, so that's the answer to the first problem. How long is the rope? Now I want to know, well, what's the area of the safe zone? How much area do they have to be safe in? So just use your second formula. Area equals 1/2 times the radius squared, which is 18 squared, times theta. And we said theta, we already worked it out, is 2/3 pi. So now when we can reduce these 2's. And what I would do here, 18 squared is 18 times 18. So then I can reduce this and say just 18 times 6 is 6 times 8 is 48, 10, 108. So 108 pi. And 108 pi, stick that in your calculator. 108 pi is approximately 339 feet squared. All right. So the only tricky thing with this part is make sure you remember your conversions and then put them into your formulas for arc length and areas. All right. There's a lot of different things going on. None of it is very difficult, but there's a lot of things. So make sure you have your notes and ask lots of questions in class, and I'll see you soon.